So, Ashmita? If you get all right, so Ashmita, if you have an error at line number 6, what is the print?
Hello, can you hear me?
Can you hear?
Yes, sir. What is the question? If you,
get an error on this line, what will it print?
والله يا
Aja? Aja, you there? Unmute. You're on mute. All right. Bhatta?
Yes, sir.
If you have an error on line number 6, what will it print? There are 7 print statements.
Okay, let me see, sir. Yesterday I didn't attend class, but
You had the videos, didn't you?
so if we have error in line number 6, right?
Mm-hmm.
Should print line number 10.
Just tell what will print. There are 7 print statements. What are the numbers will print if you have an error on line number 6?
Hold on, sir. Let me just see it. It will print 3, sir. It will come to line number 10 and print 3.
Akash?
No, I'm done. I don't have anything to do today. Just deploy. So the only doubt was that maintenance one that I need to deal with the IoT. Other than that, I'm done. Yes.
Rishta?
yes, sir. I think it will print 2, 3, 5, 6, 7.
Man, I think now on, yeah, they're gonna force me and Krishna.
Okay. If you have an, what will it print?
I think 2, 3, and it will not print 4 and cats. So 5, 6.
Error is on line 6.
So it will print only 2.
Okay.
sir. It will print only 1 and it will throw exception if 0 in the line 6. So it will just print 1 and the exceptional message.
Right. So Trisha, why would it print 2 and 6 if you have an error here?
I couldn't see that one over there. That's why I think it's down.
Okay, you have an error at this line, which is not covered inside program terminates like this. Okay, if you get error on any line which is not under the protection of try block, the program terminates right there. Is that clear to everyone? How does the program begin? Shrestha, starting from the first line, where do you begin?
From line number 3, it says main method, so print 1.
Then why did you miss
Actually, I haven't seen that
statement?
print 1 before, that's why, sir.
Why did you miss that?
Yeah, it was my fault. I could not find that one. Sorry, sir.
Okay.
Okay. I got it.
Okay. Bhakta, do you understand what exactly happens when you get an error?
Yes, sir. I got it. It will not. It will skip every It will start from the line where it goes error and will go directly to exception. It will throw exception error and to find.
Okay. So the rule is, if you get an error on a line which is not covered under a try block, the program terminates right there. If you have a try block, then you might be able to salvage something. This line is not inside the try block, so the moment you get an error here, nothing below the line will be printed. Only the first line that came before line number 6 gets printed. Is that clear to everyone?
Yes, sir. Thank you.
Anusha? Anusha? Manish?
Yes, sir.
What will it print if there is an exception, an error on line number 11?
If there's an error on line number 11, it'll print 1, 2, then there'll be a try, then it'll not print. I'm a little confused on 3, but it'll print 5, 6, and 7 after that.
5,
You know,
6.
4 will not print.
Okay. All right. So as usual, whenever you get an error on any line, the previous lines have nothing to do with this one. It is a past tense. Okay. A past tense, whatever you do here now, you cannot change the past, isn't it? Can you change the past?
No.
No. So if the error is here, this line has already been printed, isn't it? After printing this line, then you go to the next line.
Yep.
So this has already been printed. It is past tense.
Now, I was a little confused on that try catch, you know, those inside that.
Right. So it doesn't matter it is try or without a try. Whatever has been done, it's done. Okay. If you do print something before you encounter an error, that line has already been printed. So there is nothing you can change there. So yes, you are correct. 1, 2 will be printed. 5, 6, 7 will be printed, but 3 also will be printed. Okay.
Excuse me, sir.
Mm-hmm.
So we are not able to see your full screen, sir. Like the screen glitch in, I think, everyone's, screen.
Okay, let's wait until that session. Okay. All right. So Rohil?
Yes, sir.
What happens if the error is here? What will it print?
Sir, I missed the last session because I was not getting connected.
Okay. Rajan?
Sir?
What is the print statements? What will be the output if the error is here?
So we're not having any problem on number 11, right?
No number 11.
So we'll print 1, 2.
Yes.
So if we don't have any problem with the try statement, then we'll print 3 and 4, 6.
That's it.
But B by A. So we'll always have problem with number 11 since it's B by A, so 20 by 0. So we will print 1, 2, 3.
No. Okay. Imagine if it is like this. There is no error on line 11.
Okay.
The only error is on line 19.
So we'll print 1, 2, 3, 4, 6.
Very good. Okay. All right. So the catch block will only print something if there was a problem in these lines that are covered under the try block. Okay. Finally, will be printed no matter what. Error happens or doesn't. Okay. This is a guaranteed block. This is an optional block, and this is also optional. Okay. If anything goes wrong here, you might miss few lines. This will only be printed if there is a problem. And this is a guaranteed block. Okay, so in this case, if the error happens on line 19, you start from the first, it will print 1, it will print 2, print 3, print 4. No error, no problem in the try block, so it never goes to catch. Okay, it directly goes to finally. And then you encounter an error, and everything that comes after will be skipped. Okay, so it will print 1, 2, 3, 4, and 6. Okay, so is everyone clear on how try catch finally will work?
Yes, sir.
Yes, sir.
Right, print it 1, 2. Okay, did I put an error somewhere? Exception. Okay, 1, 2, 4, 6. 1, 2, 4, and 6. Okay. Yeah, the problem is it is overlapping all the messages. Okay, there you go. 1, 2, 3, 4, 6. 1, 2, 3, 4, and 6. If the error is on this line, like we said, it will print just 1. Everything that comes after is skipped. If the error is here, it will print 1, 2, and 3. Since the error happened here, it will not skip the entire program, but it will only skip the lines that are covered under try block. That's this one line, 4. Okay, it will skip 4, then it will go to catch block and print spy. This is a guaranteed block, so it will also print 6, and then finally 7. So everything gets printed except 4. One, two, three, 5, 6, 7. All right. Okay, so now that we have try catch finally, there are a couple of other things that we need to know. Throws and throw. Okay, so let's see what they are. Okay, before you know throws and throw, you need to understand the exception categories. Okay, so exception total exception handling falls under two broader categories. Okay, exceptions and errors. Okay, so there are two main categories: exceptions and error. Okay, throwable is the parent class of all exceptions. Okay, these are all classes. Okay, if you guys are curious about the try catch, right? This is actually a class. Exception is a class. You didn't write it. It's part of the JDK library. Okay, it's part of the Java library. It's readily available for you. Just like the string program. Okay, this is a class. System is a class. String is a class. These classes were provided to you free of charge by the JDK library. Okay, so similarly, these are inbuilt or library classes. Okay, now exception is the child class of throwable. Okay, throwable is the parent class of all the exceptions. Okay, now the main subclass under throwable are exceptions and errors. Okay, errors are more serious things. Okay, errors are more serious things and you shouldn't catch them. Okay, exceptions are minor things and you could catch them and take counteraction. Okay, so what that means is error is like a more serious thing. Imagine if you run out of memory. Okay, is there any amount of patch up work you can do by the program to add more memory to your laptop, to your system? Can you write a program that can buy you a new hardware that can fix your memory problem? You can't. Okay. Now the problem you might run into, your program could fail due to two things. One, there is a software issue. Okay, meaning you have some bug, or other, you have some hardware limitation or issue. Okay, so there are software limitations and software issues and hardware limitations. Okay, now if you run a very big project, you need a significant amount of hardware. Okay, can you run the entire Facebook software, the entire Facebook website from a laptop, from your laptop? You cannot. Okay, Facebook has billions of customers, billions. So 1 billion customers are trying to access your website. Your system will go crazy. Your laptop will go crazy. Okay, every laptop comes up with a default memory. Okay, so when you buy a laptop, you'll see GBs and all that thing, right? RAM and hard drive and such. Okay, so every machine has a limited amount of memory. Okay, so you can only run those applications that can utilize that available memory. If you try to go beyond that available memory, you will end up getting some errors, out of memory errors. Okay, that's when the hardware limitation caused your program to fail. Okay, software issue is more like a logical problem. There is no problem in the hardware, it was a logic issue. Like when you do int I equals 10 by 0, this is a logical problem. Your programming was wrong here, and that's what caused an issue. Okay, you did the problem was your logic. Okay, but here hardware limitations. This is just what your machine can do best. Okay, so if you have 8 GB memory in your RAM, your Java program can use maybe up to 6 or 7 GB. The remaining memory might be needed by your operating system and so on. Okay, so if you're running a website like Facebook, every customer who accesses your website, they will end up eating up your memory a little bit, maybe 1 MB or 2 MB. Okay, add up all that and you are very soon out of memory. Okay, if each customer requires 1 MB from your machine, okay, each customer who log into website, your Facebook website, they require 1 MB of your memory, because whatever they are doing, browsing, they're posting messages, they are chatting with someone, all that information will be in your machine. So let's assume each customer will eat up 8 MB of your memory when they're using your website. So how many customers can you handle? If one customer requires 8 MB of your space, how much? You have 8 GB memory, and every customer that accesses your software will require 8 MB from your memory.
Eight times 1024.
So what is 8 GB divided by 8 MB? It's a simple mathematical question, nothing to do with Java or anything.
Eight times 1024.
Yes. Okay. 8 GB is equal to 8 MB times 1024. So how many customers do you handle? Okay. It's a simple mathematical question. You cancel this and this. What remains? 1024. So with 8 GB memory, all you can do is handle 1,000 customers. That's all. So can you really run a billion customer website like Facebook from your laptop?
No.
No. Okay, when that happens, when you exceed this number of customers, you almost used up your entire memory. So that's why your program will fail with an error called out of memory error. Okay, this is the error that your program will fail with. Now, errors are more serious things. No amount of try-catch can magically add more RAM to your memory, right? Just because you write a try-catch, does it mean someone will magically add the hardware? They'll open your laptop and add additional hardware to your machine? Does that happen?
No.
It doesn't. So errors are very critical. Try-catch is just supposed to handle logical issues. Someone tries to divide by 0, you had a bad program, and you can salvage by doing try-catch. You do try-catch and you tell the customer, do not try to divide by 0. Okay, that will cause an error. Why don't you send me two non-zero numbers? Okay, this is just a logical problem. This is nothing to do with your hardware limitations. Okay, so you can salvage something and you can't do for few other things. So these are the two categories, exceptions and errors. Errors are more serious. Okay, typically like you ran out of memory. Okay, you ran out of stack memory. Okay, errors are quite serious. You cannot fix that with any amount of try-catch. Okay, you can handle anything that is software related, logical problem, your bad coding problem. You can handle them. Okay, but you cannot handle any issues that are basically quite serious. That's what the two categories are, exceptions and errors. Errors are more serious and you shouldn't try to catch them. You can if you want to, but you shouldn't. Okay, so try catch, the errors are done in the same way like how you do exceptions. Okay, you can say error and you can catch it. Okay, just like what we said exception. Okay, just like exceptions, we can also say errors. Okay, but there is no point in handling errors. Never catch errors. Okay, because errors are some serious problem and that requires your attention. Maybe your website has become more popular. So now you have more than 1,000 customers. So if you don't want to lose the additional customer, you have to buy additional memory and beef up your system. Okay, you need to buy more memory so you can start entertaining more customers. Okay, this requires serious attention from you as the owner of the software. Okay, so don't try to handle errors. You can if you want to, but don't try to. Okay, these are more serious and they require your attention. Okay, so throwable is the parent of all the exceptions and errors. Okay, the subclass of throwable is exception and error. Okay, under exception we have two categories, checked and runtime. Okay, let's look at what is checked and runtime. But you guys understand, right? What is the category exception and error? Yes?
Yes.
All right. So in exceptions, we have, okay, let me show you an example of error. This is error, stack overflow error. Okay, stack overflow error. So technically what I'm doing is I'm creating an infinite loop. Okay, from this program you call method one. So inside this method, what am I doing?
You're calling the same method.
I'm calling the same method. So you go back here, you enter again, and what am I doing?
Calling back again.
The same method. So you're going in circle, right? Infinite loop. Okay. So every time you call a method, what happens in the memory? I showed you yesterday. Every time you call another method, what happens in the memory?
Stack.
We stack them. Okay, we store it like this. The main method called method one called method two called method three called method 4. We keep stacking so we can remember how do we go back. Okay, so when the method 4 has done its job, you need to return back. You need to return back to whoever called method 4. So to find out that, to remember that, we have something called stack memory. Okay, so there is a specific location in your memory, in your RAM, which is dedicated for this job, to remember who calls whom. Okay, the main method called method 1 from line number 5 called method 2 from line number 9 called method 3. So this is where we remember which method calls whom. So whenever one method has done its job, okay, we go back to whoever called method 2. Then when method 1 completes, we go back to whoever called method 1 and then continue with the next line. Okay, so that's what we call a stack memory, where we store all the method details. Okay, now when I create this infinite loop, method 1, what happened? Method 1 calls method 1, method 1 calls method 1. This keeps on growing. So memory is not infinite. You know that, right? Everyone has limited amount of memory in their hardware, in their system. So if this stack keeps growing forever, infinite time, won't you run out of this memory pretty soon?
Yes. Yes.
So that's what I created here. Okay, when I did an infinite method call loop, I created an error, which is stack overflow error. Okay, so this stack that we store where all the method names, this is literally overflowing. Okay, because I ran out of this memory, stack memory. When I ran out of this memory, you get that error, Stack Overflow. Okay, so that's an error. This is a serious problem. You cannot just tell user saying, you know what, enter a non-zero number. You can't say that. It's not that simple. It is a very serious problem, and the developer, the owner of this software, has to seriously look into this problem. Okay, so that's an example of error. What we saw yesterday was an example of exception. These are more of a logical problem. Okay, this is more like a simple problem that you can put a band-aid on and try to make up for whatever happened here. Okay, you can salvage whatever you want to by handling exceptions, but errors are a more serious thing. Okay, errors are more serious thing, and it requires immediate attention from you. Okay, so don't try to catch errors. Okay, so this is an example of Stack Overflow. All right. So exceptions, as you see, come under two categories: checked exception and runtime exception. Okay, so let me show you what they are. Checked exception is also called compile time exception. Okay, and then you have a runtime exception. Okay, so there are two categories: runtime and compile time. So what do you guys understand? You have come across this term before: compile time and runtime. You have heard these terms before, haven't you?
Yes, I think one will show exception while we're running the program. Otherwise, whereas other one will show after we compile the program.
Mm-hmm. So to show this exception, you have to actually run the program. Okay, you won't see it at first. Now, when I did this problem, right? When I did create this problem, do you see this error now, right now? Do you see any complaints from the Eclipse editor that this line will cause an error?
No.
Right? You don't see that. You don't see any red marks or anything. This, whatever exception this line causes, this is a runtime because it requires me to run this program. Only when I run this program, that's when I see that error. Okay, so this exception that you're looking at, arithmetic exception, this in fact is a runtime exception. It requires you to run the program. Okay. So before we go further, what do you make out of this? Okay, if I write something like this, what would you understand?
It is package.
Yes. Okay, so remember this clearly. This part is what we call fully qualified class name. Fully qualified class name. A typical program is defined by its package, then the class name, and finally the method name. Okay. If you see a parenthesis followed here, meaning this is a method. Register is a method. Okay. If you see a parenthesis followed by, this is a method. This is a method in which class?
Customer.
Yes. Register is a method in customer class. If this is a customer, then what is this? If this is a class, customer is the class, then what is this?
Package.
It's a package name. See? So that's how it happens. Now, here,
बोलिरहेको भयो
If an error is caused in this line, what will it print as? Remember this. If error happens in this line, how will it print?
com.ey.www.shopping.products.method4.
Very good. Okay, this is how it will print. Okay, method 4, line number 6. Okay, starting with the package name where the program is, it's in com eBay www shopping. After the package name, you have the class name, followed by the method name, and finally the line number. Okay, so when you see a stack trace like this is how it prints. Okay, now arithmetic exception is a class. Okay, can you guys guess which package the arithmetic exception is in?
Exception.
Yes,
Java.lang.
java.lang is the package. Okay, how about the system class? Which package is system class from?
Java.lang.
Java.lang. Okay, so if you guys do not believe these are classes, you can just click on them. Click on them and it will show you the class. It's a class. System is a class. You didn't write this, but it was written by the Oracle team, the Java company. Okay, if you go to arithmetic exception, this is also a class. Okay, typically you'll find all those in here. Okay, we call them as inbuilt programs. Do you see this library? This is a library which is ready with all the helpful programs for you. Okay, here you see this. These are the packages, and these are the classes under those packages. So if you're curious about this particular program, just go to java.lang. Okay, these many programs had been provided to you without your knowledge. It's ready to use. Go to java.lang, and here you'll see arithmetic exception. It's a class. It's a program. Okay, it was already provided to you when you installed JDK. It's provided by JDK installation itself. Okay, so similarly, all the exception program that you are seeing here, exception class, error class, they're all here. System class, throwable, error class, exception class. These are all classes. Okay, these are already provided to you by JDK installation. And what do we call them? They are part of your library, JDK library. Okay, it's part of the library. It was provided to you when you installed JDK. Okay. All right. All right, so that's what the package is. Now, like I said, arithmetic exception, this particular exception belongs to which category? Runtime or compile time?
Runtime.
Runtime exception. Okay. How about this? Now, will this cause an exception? The array size is 2, and I'm trying to print the item number 3.
Yes.
This will cause an exception. But is
Yeah.
it forcing me when I'm writing the code? It's
No.
showing me that this line will throw an error.
No.
So is it compile time or runtime?
Again, run.
So runtime. So you run the program and you will see you got an exception. Array index out of bound. Okay, array index out of bound exception. It's a runtime exception. Okay, now what do you remember of the most infamous exception? Every time your program failed, you might have seen that. From day one, you guys have seen that. We already discussed it, why it happens. Do you guys recall what it is?
Null pointer exception.
Null pointer exception. So here is what you guys need to pay attention on. The null pointer exception is the most infamous exceptions. Okay, this is the cause of your program failure almost 99% of the time. 99% of the time, whenever you get error, it will most likely be due to null pointer exception. So pay attention here. Okay, this is the most difficult, most common exceptions. Okay, and you need to understand why it happens. Okay. Now, what is the value of P? What is the value of P variable?
Null.
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 Okay. P's value is null. If you don't assign anything, okay, if you don't initialize this object, okay, if you do not initialize the object, the default value of object is null. Okay, meaning there is nothing in the memory. There is nothing in this memory. So if I say p.stock, will I get anything if the memory was never assigned to the p object? Will you get anything from that?
No.
You won't. If there is no memory ever created for this variable, then there is nothing to read from. Okay, you cannot drive a car which never existed. Okay, imagine if this is your car, okay, and this is what you're doing. Okay, you're printing this. Okay, let's say S for speaker. Okay, the speaker in your car. Car C, you declared this car, but did you create this car? You haven't. Okay, how do we create car object? We say equals new car. Okay, when we say equals new car, that's when the car object got created in the memory. Okay, but this meaning you have an idea that you need to own a car, but you never got one, you never bought one, you never created one. So if your car does not exist, you just have an idea here. If your car does not exist, can you access the speaker of that car?
No.
You can't. Okay, that is the problem. So anytime you use a dot operator, you're trying to access something. You're trying to access the speaker of the car, or you're trying to access the steering, or maybe you're accessing the methods, drive, start, stop. Okay. If the car does not exist, you cannot access anything. You cannot access variables, and you cannot access the methods. If the car does not exist, you cannot access the attributes, speaker, steering, whatever. and you cannot access the method. So typically a null pointer exception happens if, remember this point, okay, remember this point. This is the cause of 99% of program failures. So pay attention. Whenever you apply a dot operator on a variable which is null, okay, C variable, what is its value? It's null. If you apply a dot operator on a variable which is null, you get null pointer exception. Okay, so let's see that. Null pointer exception. Which line number this error occurred? The exact line number? Look at the exception message and tell me.
4.
Customer.java, line number 4. So this is your culprit, this line. In this line, what you need to check is, are there any variables that I applied dot on? Yes, there is one variable, C, that I applied dot on. Okay, so most likely C is null. Yes, C is null, and that's why the error. If you had done this, if it was not null, you wouldn't get the null pointer exception. Okay, driving basic car, I was able to access the drive method, no null pointer exception, because this variable was null. If this variable is not initialized, what do you get? Null pointer exception. Is that clear? Did you guys understand?
Yes.
Yes.
So I have a bunch of objects, variables here. Global variables, there are 3. And local variable, there is 1. Okay, so altogether, method 4 has access to global variables and the local variable. From each variable, C, P, S, and S2, from each variable, I am trying to access some information. Information S, I'm accessing from the car object C. Stock, from the product object P. Name, from the student object S. Another name from student object S2. So where will be the null pointer exception?
On line number 9.
Line number 9. And why?
Because the student S, it's not initialized, it's just null.
Yes. This variable is not initialized. If you do not initialize, the default value of objects are null. You don't have to explicitly write equals null. The default value of all the objects are null. So yes, line number 9 is where you get the null pointer exception, because S is actually pointing to null, and you try to invoke dot. null pointer exception on line number 9, customer.java. Customer program, line number 9 is where you got the error. Okay, so do you guys follow? Do you guys understand?
Yes, sir.
Yes.
Yes, sir.
All right, so where is the error now?
Seven and 9.
You should get an exception like this, null pointer exception with red marks. So which line is it? Yes?
Maybe none of them.
None of them? 7 and 9, what else? Any other answers? Think.
7.
7, yes. So first of all, you cannot have exceptions in two lines, 7 and 9. What happens if you get an exception on line number 7? Do you proceed on next lines?
No, program will terminate there.
Program will terminate there, okay? But that's not the right answer either, okay? Do you see any errors? Is there any exceptions?
No.
No. So 7 and 9 is not the answer because first of all, if the program had a problem on line number 7, you never proceed on the next line, okay? 7 is not the answer either. So remember again, why will you get the null pointer exception? Recall, what did I say?
When you apply dot operator on variable which are null.
Very good. So remember that, guys, I'm repeating this because this is the error, this is the exception that will haunt you throughout your career, okay? This is the exception that will be behind you for as long as you will be a Java developer. For as long as you guys are Java developer, this particular exception will be appearing in front of you for 90% of the time. So be very careful when I explain this. Listen, not just accessing the variable, okay, P is null, S is null. Just because I'm accessing the variable, does that mean it will cause exception? No. The exception will cause when you apply dot on that variable. Okay, if you just print P, it is printing null because yes, P is null. P variable is null, that's what it is telling you. But did you apply the dot operator on P variable like what we did for S2 or C?
No.
We didn't. So why should it cause null pointer exception? Null pointer exception only happens if you apply the dot operator on a variable which is null. P and S are null. Yes, granted. But did we apply dot on P and S?
No.
So that shouldn't cause any problem. Now that you apply dot, where will be the error?
Line 7.
7.
Number 7. Because we found a variable which is null and we applied a dot operator on that. Line number 7 is where you have the null pointer exception. So is that clear? What is null pointer exception? How will it happen? And how do you fix it? Is that clear?
Yes, sir.
Yes.
Where will be the error? Okay, let me make it a little tricky. Okay, imagine if someone else is sending you these parameters. Where will be the error and how do you fix it? This is what you have programmed. Where will be the error?
Line number 4.
Which program? What line?
Customer program line 2.
Customer program?
Line 2.
Line 2. Here?
Yeah.
Okay, what's causing the error?
It's accessing the static variable.
That's not the problem. Why do you get the error? When do you get the error? When do you get null pointer exceptions? Come on, guys.
So if the object is not initialized,
Yes.
so here we will get error on line 4.
Right. Last line number 4.
Student S, static student S, if we make it as a new student, then we will not get any error.
Yes. So now method 4 requires 3 objects: a car object, a product object, and a student object. So who is passing objects, the car, product, and student, to method 4?
Line 8.
This line is where we're passing car object, CC, a product object, P, and a student object, S. Does any of these variables seem to be null?
Student
Student is null. It is declared, not initialized. So when you pass S, what is the value of S here?
Null.
Null.
Null. So you pass a real car object, you pass a real product object, and in place of S, what you send to method 4?
Null.
Null.
Null. Okay, so from this program, when you jump here, you got the real object for car, you got the real object for product, and what you got in place of student S here is null. Okay, you got null. So when you come here, which line will give error? Look carefully.
Line number 4.
So which variable is null?
S.
S.
Student.
So we are applying dot on S.
Oh, no.
We didn't apply dot on S. So S is null, st dot name is Mike, and p dot stock is 100. Now, where is the error and where will you fix it?
Line number 3 on the customer class.
Okay, and which part of this whole line is the culprit?
S dot name.
S dot name is the culprit. Okay, so sometimes when you're looking at a problem, it might not, the fix might not be here, it might be entirely in different place. Okay, the fix might be required in an entirely different place. Okay, so what you have to do is something like this. I'm explaining you how to debug. Okay, so what you do is you right click on this, say reference in the project, meaning you will get the details on whoever is calling method 4. Okay, so when you say right click, reference, project, this is the line which is calling method 4. Go to that line and see. Okay, from here I'm calling method 4. To ensure there is no null pointer exception, you have to make sure the main method is not sending null as any of the variables. CC should not be null, P should not be null, S should not be null. If none of these are null, then you won't have a problem here. Okay, if any of these are null, you'll have a problem. So check in this program, where is the CC variable?
Line 6.
Line 6. Is it initialized and not null?
Yes.
So you're good with the first variable. How about P?
It's initialized.
P is also initialized and not null. So you're good with the second parameter. So this is how you it's like you play an elimination role here. Okay, you keep eliminating whatever variable might be causing this error. So once you eliminate everything, then you will find what's the root cause. Okay, how about S variable?
It just declared, so it has null value.
So the problem popped up here, but the fix is where?
Line number 3 on the test student class.
Yes, this is where the fix is. Okay. Okay, without this, what do you get? You get a null pointer exception. Okay, so you can do the reference thing, right click, reference in project, you can do that, or you can just see the error message. Here itself, it will tell you everything. Method 4 was called, when you got the null pointer exception, it happened on method 4, customer, line number 3. This is where the error happened. Who called customer method 4? Just check the next line. This is the person who called method 4. So you will see that in test student line number 8, from this line, I called customer method 4. So go to this line. So here, this is where one of the variables, CCPPS, one of this variable is null. That's causing the null pointer exception. Okay, so you see everything, CC, initialized, P, initialized, S is not initialized. And hence, you do this and fix the error. No more errors. Okay, remember, this is critical. You need to be capable of finding out where the problem is and know how to fix it. Null pointer exception is, no matter how experienced you are, this exception will happen to everyone. 90% of the time, this is the reason for your program failure. This is the reason your customer is not able to pay the bill. This is the reason the customer is not able to log in. This is the reason customer cannot place order. 90% of the time, this is what will cause the problem. So it is very important to find out how to fix that problem, how to find it, which line number. Okay, you have to be capable of finding out that. So, do you guys understand how to find out where the problem is? In particular, the null pointer exception?
Yes, sir.
Yes.
Yes, sir.
All right, so we looked through plenty of exceptions. Again, while we are here, what is the null pointer exception category? Is it compile time or runtime?
Runtime.
Runtime. Okay, we know that one of this might cause error because we are using dot. And if you are the programmer for customer class, and this was written by some other developer, your team member, okay, you cannot know what the other programmer is doing, how the other programmer is calling your method. You can never guess that. Okay, you can never predict that. So when you look at this program, you cannot be sure if C will be null or P will be null or S will be null. Okay, so as a good developer, anytime you receive input from an untrusted resource, from an untrusted source, your job is to make sure they are not null. Okay, if you receive an object from other programmer, other program, your job is to do this. Always do a null check. If C is not equal to null, what do I do if I have to check P and S as well?
And
And P is not equal to null, S is not equal to null. Okay, if none of these are null, if C is null, if C is not null, P is not null, S is not null, then you can proceed with the dot operator coding. Okay, every time you receive something from an other source, other programmer, other developer, your job is to make sure you do a null check before you invoke the dot operator. Before you call dot operator on any of the variables that you received from someone else, you have to do this null check. Okay, this is the best coding guideline. Okay, and then you can just say invalid input. Okay, if you don't want to cause any problems, you can always write a code like this. Okay, it's not like you will be writing the code for entire Amazon website or Facebook website. There will be a lot of other developers who will unknowingly make mistakes. They'll forget to initialize, they'll pass you. So you cannot trust that they will do the right thing. They will be vigilant in initializing variables and all that. You cannot guarantee that. It's a human error. Okay, there is no personal thing about that. It is just a human error. Okay, when we declare variables, sometimes we forget to initialize that. Nothing personal. Okay, but you cannot blindly put your trust into that. Your job is to make sure the other person who is calling your method, they don't cause your program to fail. So this is the best ideal programming. Whenever you are using dot operator on a variable that you received from someone else, what do you have to do before that? Null check. Is that clear? Yes?
Yes.
All right, so your program did not crash and you gave proper input. Okay, you gave proper message. I did not print this message because what you sent me is invalid. Whatever you sent me is invalid. So I cannot print the student's name, I cannot print the car, I cannot print the product stock, I cannot do any of those things because whatever you sent me is null. Always do a null check if you want to avoid null pointer exception. This line will only be executed if none of the variables will be null, isn't it? If this condition satisfies, only then you enter the if block, isn't it? Yes? All right? You're printing the message only if none of these are null. Okay, so let's go back to this thing now. Okay, are you guys familiar with all the runtime exceptions now? There are quite a few, and you're already introduced to few of them. Array index out of bound, is it runtime or compile time? Array index out of bound.
Runtime.
So runtime. Null pointer exception.
Runtime.
Arithmetic exception.
Runtime.
Okay. They're all runtime because nobody forced you to fix that error or handle that error. Okay, nobody forced you. Okay. Now let's see a compile time error now. Now, don't worry about this line. Okay, so just remember that like system program, the string program, file is another program found where?
JDK libraries.
In the JDK libraries. Okay, inbuilt program. These are inbuilt programs in JDK library. Okay, you got these programs as part of JDK installation. Okay, they are inbuilt Java programs. So this is one of the Java inbuilt program that allows you to create files on the hard drive. Okay, if you want to create a file in, let's say, D drive. Okay, if you want to create a file here, or what you do is you say like this. my new file.txt. You can do this. Okay. So when you do this, it will basically create a new file in your hard drive. Okay. Now, what are the ways this might cause error? Okay, if I ask you to create a file in whatever location I tell you, what are the ways you might end up having problems?
But for the
Same
So
name
here,
does already exist.
the directory does not exist. Now I'm saying I want to create a file in the location E drive. Okay, so do I have a E drive? Okay, so there is a ROM drive, so I'll say Z drive. Okay, so how many drives do I have here? I have C, I have D, I have E. Do I have a Z drive?
No.
So if someone asks you to create this file in the Z drive, won't you get an error? There is no Z drive on your machine. It's an invalid path, isn't it?
Yeah.
So when you're trying to create a file, you might get an exception. If the path is fine, okay, if the path is fine, there won't be a problem. I have a C drive, okay, and in the C drive, I can create this file. No problem there. In the C drive, I can create a file here. But what if your path is wrong? You never had a Z drive. Won't you get an error?
Yes.
Yes. So when you're creating a new file, you will get an error. But unlike null pointer exception, compile time exception, is my program forcing me to handle that failure scenario? Is it warning me that this line might have a problem? Might have problem.
Yes.
Okay. Did you see that happen when you were writing a null pointer exception program?
No. No.
So this particular error, this particular exception, is it a compile time or a runtime?
Compile time.
It's a compile time exception. I didn't have to run the program to find out that there is no Z drive. When I'm writing the code, when your code is compiling, that error pops up. So what is this error? IO exception, input output exception. So there is an exception. If you're trying to create a file and that drive doesn't exist, you'll get an exception. Okay. So this kind of an error, this kind of an exception is what we call compile time. Okay. If your program forces you to handle that right now, this particular category, IO exception, this particular category is compile time exception. Okay. So you have a runtime and you have compile time, which is nothing but checked. You need to check this exception when you're writing the code. When you're writing the code, that time itself, you have to check that exception or handle that compile time exception. Okay. So you guys understand the difference between runtime and compile time? When will you encounter that?
Yes.
Now let's see, what is the Eclipse suggestion? Eclipse gives you two possible fixes here. Add throws or surround with try catch. Let's try the second one, which we are already aware about. If you know that some line might throw error, what do?
Put it on the try block.
Put it around the try block. If you know that this line might cause error, you wrap it inside a try block and give a catch. Okay, you give a catch. All right, this is fix number one. You have to put a try catch around that line which might throw an exception. Okay, So here, this program called the customer program, okay? Okay, the main method called method 4. Okay, the main method called method 4. So in method 4, line number 7, you had a chance, you had a possibility that there could be an error. So you had two choices. Either you wrap this code in a try catch, as we usually do. Okay, if you suspect this line could throw error, you wrap it in a try catch. That is option number 1. So the second option is throws declaration. Okay, what throws declaration means is you don't want to handle it. Okay, when you write try catch around the potentially problem line, you are handling the exception yourself. Okay, yourself in a sense, method 4. In this case, method 4 is handling this problem. Okay, method 4 is handling the problem. The other option you have is you won't handle the problem, you will throw it. Okay, there are only two possibilities, right? Either you throw or you handle. Okay, you handle the problem yourself or you throw the problem back to whoever called you. Okay, so here, look carefully. When I say throw, now who did you throw this error to? When you added this, who did you throw this error back to? Where do you see the error line now?
Line number 7 on the test student class.
This is where the problem popped up. Okay, now here was the problem. Okay, the error is not here. The error is on method 4. So the method 4 developer has two choices. Either they handle it by saying try catch. Okay, either the method 4 programmer can handle it by doing try catch. Okay, that is option 1. The second option is you throw it to other person. So when you throw it, who gets the responsibility? Whoever is calling method 4. Now method 4 gets the same option. Do you want to handle it yourself with try catch or do you want to throw it back? Okay, look at this. Method 3 is calling method 4. Even that person got the same message, just like the main method. Now what happens if I say method 3 doesn't want to handle it, but wants to throw it? Where will the error pop up now? Method 3? Okay. The main method called method 1, method 1 called method 2, method 2 called method 3, and method 3 called method 4. Okay. So this is the entire story from main method to method 1 to method 2, method 3, and method 4. Now when I say I don't want to handle it myself with try catch, I want to throw it. Who gets the error?
Method 4.
If you throw error from method 4, where does it go back? Method 3.
Method 3. Method 3.
Whoever is calling method 4, In this case, it is method 3. So when I do throw, who got the error?
Method 3.
Method 3 decides it doesn't want to do try catch either and decides to throw. Where does the error go?
Method 2.
The exact line number where the error will pop up.
9.
9.
Isn't this the line where you're calling it? What will happen if this line says I want to throw it?
Goes back to method 1.
Error on line 6.
Line 6.
6.
Yes. Here, if I say surround with try catch, who will get the error?
Method
No one.
1.
Method 3.
Okay. If you surround with try catch, meaning method 1 is planning to handle it. So no one will get error. If you do try catch, see, someone in the chain has to handle the problem. Okay. If there are 5 persons in the chain, someone has to take the blame, isn't it? If everyone starts throwing it back to the other person, where does it land? To the very last person, isn't it? The same rule applies here. If someone in the chain decides to handle the problem themselves, that's where it stops. From method 4, you throw it back to method 3. Method 3, you throw it back to method 2. Method 1 did not throw it back to anyone. So did you throw anyone or did you handle it yourself?
And ourselves.
You handled it yourself. Handling the exception means try catch. If you have the try catch block, meaning you are handling it. Okay? If you have a try catch, meaning you are handling it. If you do not have try catch, it means you're planning to throw it back. So if I throw and not do try catch, what will I get? Where will there be error, or will there be no error? If I decide to do throws,
Line 7 of the main method.
yes. Now here, if you say try catch, where will the error pop up?
Nowhere.
Nowhere. Try catch meaning you are handling it. Okay? Try catch meaning you are handling it. No one gets the error. Okay? Throws is a way to let other person handle the problem rather than you doing it. Okay? You will let someone else handle the problem. That's what throws meaning. So anytime you get an error on any line, you have 2 options. Okay? If any line is throwing error, you have 2 options. Either you do try catch and handle it yourself in the method 4, or you throw it back and whoever is calling method 4, they will get the error. Whoever is calling method 4, they will get the error. That is throws. Try catch meaning you are planning to handle the exception yourself. Throws meaning you're throwing that responsibility to someone else. Okay? So either you do throws, meaning you're warning the other person. Whoever is calling my method 4, remember, it might throw this exception. So your job, whoever is calling method 4, it's your job to be prepared for this exception. I might throw this message to you. You handle it any way you want. So whoever is calling method 4, they can decide if they want to throw it back or handle it themselves by try catch. That's the next thing you need to learn, throws. So do you guys follow when to use throws? Yes? All right, so you have compile time, runtime for exceptions. You know about errors. You know what a try catch is. Specifically, you know what a null pointer exception is. Okay, and then you know what a try catch is. You know what a throws is. Okay, there's one more thing remaining. Throw. Okay, throws is if the developer of a method does not want to or wish to handle exception with a try catch, they can decide to throw, they can let the other caller handle it with the keyword throws. Okay, when you say throws, you're letting the other person who is calling your method handle it. Okay, you let the other caller, in this case, who is the caller for method 4? Who is the caller for method 4?
Method 3.
Method 3. Okay, so you're letting the caller, in this case method 3, decide whatever needs to be done. Okay, that's what you do with the keyword throws. Okay, now you can, if you are planning to throw more than one, you can do that. Okay, you can throw as many exceptions as you want. Let's say here you can decide to throw another exception, null pointer exception, okay, with a comma separated. If you want to throw multiple exceptions, you can do that using a comma separated. I might throw, okay, this method might throw IO exception and null pointer exception, okay, is what I'm saying from here. Okay, so you're warning the caller, whoever wants to use my function, my feature, method 4, be aware, I might throw IO exception or null pointer exception. I might throw these two. So be prepared to handle both of them. You're telling the other person. Okay? So my question to you is, if this method is warning the other person that I might throw IO and null pointer, okay, I might throw two exceptions. Here I wrote just IO, not null pointer. Why is it not warning me? Why is it not forcing me to write null pointer here as well?
Because it's unchecked exception.
Yes.
Runtime.
It's an unchecked runtime exception. If it was a compile time exception, then you would have seen that. Okay. The editor, the Java editor, Eclipse, will only force you if you are throwing a checked exception or compile time exception. If you're throwing a runtime exception, it doesn't force you. Okay. If I remove this, if I just write null pointer exception, will I get error? See here. If I write throws null pointer exception, I still have this. Okay. But if I just have IO exception and no null pointer, you don't have the error. There's no warning. Nobody complains. Because IO is compile time or checked exception, and this is unchecked or runtime exception. So you are only forced to handle checked or compile time exception. Remember that. Okay. All right. So before we learn what a throw is, let's look at other problems. Okay, let's look at another problem. There are usually two kinds of problems, okay? Okay, so there are typically two kinds of problems. One is a programming syntax error, okay? Now, this is the problem because of your code. Okay, this is the line which is causing error because you had a bad program. Okay, so this will happen because syntax-wise, programming-wise, there is a problem here. Now, the other type of problem is business reasons. Okay, so if someone tries to withdraw 200 and your balance is 100, if I do this, okay, if I do this, will my program fail?
No.
No. Balance is 100. What is 100 minus value is 200? What is 100 minus 200?
Minus 100.
Minus 100. We are assigning that value back to the balance. So balance will have minus 100 value now. So are integers allowed to, can integers have minus numbers? Yes.
Yes.
Minus or positive, isn't it still a number? It is still a number. Integers can have minus values. So Java programming wise, is there any problem with this line when you minus balance and amount? Is there any problem technically?
No.
No.
No. Your program will not fail. Everything will be fine. Programming wise, there is no problem in having a negative number in an integer variable. It is perfectly okay. You can have a negative billion number. Nobody will complain you. Okay? You can have a negative billion number. There is no problem with this. It is perfectly fine. But here is the question. Business reasons. Logically, does a bank allow you to have a negative billion number? Will it allow you to withdraw $1 billion when you have zero in your balance?
No.
No. For business reasons, for your company's policy, no one should be allowed to withdraw more than what their balance is. No one should be allowed to withdraw more than what their balance is. Not -1 or not -1 billion. So here, programming wise, there is no problem. You can have minus billion in an integer variable. Perfectly fine. But business reasons, due to your company's policy, they don't want you to have a negative number in this integer variable. Okay? They want you to throw an exception. If ever this value goes below negative, below zero, they want you to throw an exception and stop it right there. So you see, there are two kinds of exceptions. One, because programming wise, it is not allowed. Okay? Your program does not allow you to do this. If you do this, there will be error. This is an infinity number. I cannot store infinity in I. This is a programming failure. Your Java will complain about this line. But this line, Java does not complain. Your manager, your company owner will complain if you allow them to withdraw more than their balance. So there is a logical problem, logical or business problem. Okay? And this one is more of a programming problem. Do you guys understand the difference?
Yes.
So if you are a cell phone provider company like AT&T or something, what would be your check? Let's say you're writing a method for call operation. Okay, give me the number and I'll call you. Okay, now here, is there any problem in storing 1, 2, 3 in a long data type phone number?
No.
No.
Does Java complain about this line by any chance?
No.
No. But is it a valid number? Can a phone number be just 3-digit, 1, 2, 3?
No.
If it's emergency number.
So is this a business failure or a programming failure?
Logical problem.
It's a logical business problem. Your employer, your company head, they have set up this policy. No one can have just a 3-digit phone number. You should have at least 10 numbers. So there is no problem with the long data type to store 3-digit number. It can easily store 1, 2, 3, or even 10-digit or 11-digit. Long data type doesn't have a problem with what value you store. Your company has a problem. They cannot dial a number which is just 3-digit. They cannot dial that. A valid phone number is 10-digit. So this line would be a business failure. Not a logical, not a programming failure. Your Java won't complain, but your business, your company will complain.
Business
So you understand the difference between these two?
Yes.
Yes.
Okay. So for this kind of a scenario, let's come up with something. Okay, this one, we don't have to worry about it. Java has an inbuilt program, arithmetic exception. And even if you don't do anything about this, there will be a exception thrown. Okay, but to handle a scenario like this, logical business problem, you have to do a little bit more. Okay, you have to create a new class of your own. Okay, let's call it insufficient fund exception. Okay, you have to create a new program of your own. Okay, so what you do is you create a new class and you say extends exception. Why do we say extend exception?
It can edit all the exception and error.
Because all the exceptions, null pointer exception, arithmetic exception, array index out of bound, IO exception, they are all subclass of which class?
Exception.
Exception. Okay, so here runtime exception as in null pointer exception. Okay, this is a runtime exception. If you want to see that, you can just see here. There are so many programs that are inbuilt, okay, and ready for use. Okay, I have a null pointer exception right here. This is a program that they gave you. Now look at what this exception is. Who does null pointer exception inherit from?
Runtime exception.
Runtime. Let's go to that class. Where does runtime inherit from?
Exception.
Exception. Okay. So if you have to create a new exception of your own to handle this scenario, okay, you want to handle this scenario. If balance is lower than the withdrawal amount, you want to throw an exception of yours. So you have to do the same thing that this inbuilt program does, don't you? You have to do the same thing that the inbuilt program does. And that's what we are doing here. We created a new exception. We want to mimic what the null pointer exception does, array index or bound of exception does. We want to mimic them. In order to do that, we do the same thing that the other classes do. We create a new class and we say extends exception. Okay, you guys understand? Yes?
Yes.
Yes.
Okay.
Yes.
And one more thing you do, create a constructor and do this. Okay, do this line. Do this line. Okay, so insufficient fund exception is what you created. And you say extends exception. Okay, and then you create a constructor. Now when you create a constructor and pass this message, what is this line doing? What does that line mean?
Calling the constructor exception class, parent class.
You're calling the constructor of your parent, super, which is this one. Okay. The reason we do this is because if someone wants to pass a message, don't you want that to be passed all the way to your parents so it will be properly propagated? If you want to pass your message to the end, you need to make sure you initialize your parent constructor with this message. Okay, so when you create a new exception like this is all you do. If you want to create a new invalid pin exception, all you do is create a class invalid pin exception, extends exception, constructor invalid pin exception, message, super message. All you have to do is change this and this. That's all. Okay, change this and this. That's all you have to do. Invalid pin exception, invalid pin exception. Invalid user ID password exception, invalid user ID password exception. Okay, so basically you're creating your own exception. All right, so if this is what we call user defined exception. Okay, what is null pointer exception? It is an inbuilt. Okay, this program was already built in the JDK, inbuilt exception. And this is user defined exception, meaning we as a Java user, we defined it. We came up with this exception. This is a user defined exception that we created ourselves. And this is the exception that we got from our JDK installation from the library. Okay, inbuilt exception and user defined exception. Is that clear? Will you remember the term user defined versus inbuilt?
Yes.
Sir.
Okay. All right, so how do we force this line to throw error? How do we force this line to throw an error? Okay, let's see that. Now, what is your business logic to throw the error? When do you want to make sure this line causes an error? What is your logic? What is the condition for throwing exception?
If amount. is greater than
Less than
balance.
If amount is greater than balance, okay? If you're trying to withdraw an amount which is more than what you have in your account, in this scenario, we want to make sure we throw an exception and not do this. We don't want to put the balance in negative, because in that case, bank will end up paying out of pocket. So we don't want to do this, okay? Else we'll do this. If amount is less than balance, we will go to else block, isn't it?
Yes.
So this is the line where I want to throw the error. I want to create an exception in this line if amount is greater than balance. Okay? If amount is not greater than balance, you will end up in the else block, which will allow you to deduct that and let them withdraw the amount. Okay? So this is where the throw keyword comes. Okay? So what you do is something like this. Create an object of your custom user-defined exception. Insufficient fund exception. Okay? Create an exception object first. Now, what is this error for?
Constructor.
Constructor. Okay, the insufficient fund exception constructor requires
A string.
String parameters.
okay, so you have to pass a custom message here. What I'll say is your balance is, read it from the variable. Okay, please withdraw less than balance. Okay, please withdraw less than balance. Now you created a new object here of your insufficient fund exception. This is where the next keyword comes in. Throw that object. This is where you are simulating. Okay, you are simulating the exception. Okay, you are coming up with your own exception. You want to throw your own exception. Okay, so what do we say? Throw this exception. Now, when an exception is happening in this line, what are your options? Remember the compile time exception. If this line is throwing an exception, what do?
Try catch or throw.
Yes, you do a try catch around this line or you throw. So what I'll say is I want to throw this exception. Throws insufficient fund exception. When I throw from here, who gets the error?
The method caller. The test student class.
Whoever is the caller of withdraw, which is this one. Okay, so here I have two options. I will surround with try catch. Okay, I'll surround with try catch. Right? Withdraw 10, withdraw 20, withdraw 50, withdraw 60. Okay, let's see that. Okay, successful withdraw. Okay, so you have a balance of 100 and you withdraw 10 first and then 20, then 50, then 60. If at any point any of these causes error, it will print you. It will print the error. It will print the exception that you custom created just for your business logic. There is no programming wise, there is no problem having a negative number, but you decided if the amount is less than balance, you want to throw an exception. Okay, you decided yourself. Okay, so what we'll do, the first three were successful withdraw. 10, your balance is 100. The first withdrawal is successful. When you deduct 10 from 100, what is the new balance?
90.
Second transaction, what is the new balance?
70.
70.
Third transaction, what is the new balance?
20.
20. So the first three were fine and you had a balance of 20. Then you tried the fourth transaction to withdraw 60. Do you see this custom error message which looks just like your null pointer exception? This is what you caused. There is no problem in having a negative number. You created this yourself because this was causing a business error, not a programming error, but your business reasons. You created this error yourself. Okay, with a proper message to the user. Your balance is 20. Please withdraw less than 20. This is the line where the error happened. When you tried to withdraw 60, when your balance was 20. Okay, so now you understand how to create custom exceptions of your own. Remember this, every company that you work for will have some rules, business failure rules, like this one. A telecom company might have rules on what is the phone number size, how many digits it should have. For a banking, insufficient fund is an exception. For online shopping, what kind of exception you might have? Just guess. Not a logical, not a programming error, but business-wise, what they might see as an invalid
Product quantity, like out of stock.
Yeah. Okay, if you just have like 10 in your warehouse, in your stock, and if the customer tries to order 20, the stock value will be minus 10. So is that a valid inventory number? Can inventory go in negative? No. Integer doesn't have a problem with negative number, but literally in the warehouse, if there are 10 items, you say 10. Can you ever say minus in terms of stock, in terms of inventory? No. So with online shopping, isn't having a negative number for stock a problem? So if Java is not throwing error with the negative number in your stock, what do you do?
Build our custom exception.
You create your own custom exception. Okay, out of stock exception. You create a new class called out of stock exception and you do the same thing here. Just copy paste it. Extends exception, public, out of stock exception, string message, super, do this. Create a new class of your own. In your program, whatever logic you have, the order is greater than stock. Balance is greater than amount. Sorry, amount is greater than balance. Whatever logical reason you have, check that. And if that logical reason causes any concern, what do? You create an object of the class that you created and you say throw that object. Okay, so here you're basically creating exception of your own. Okay, your program is throwing exception, not a Java thing, but your own program. Okay, so this is how you write it. Every company, every project that you go, they will have a custom exception of their own. Okay, which is like a business failure in their mind. Okay. So you have user-defined exceptions and you have the throw keyword at last. Okay, so you say throw when you want to create an exception in this line. Okay, whenever you want to raise an exception of your own or an existing one, you say throw. Okay, if you want to throw an exception of inbuilt, you can do that as well. Okay, so you can throw an inbuilt exception on purpose, null pointer exception, or just exception. Okay, you can create an inbuilt exception of your own and say throws. Okay. Okay, so this is a line where you decide if you want to throw exception yourself. Not Java's concern, but this is your concern. Okay, but rather than using the inbuilt class, it always makes sense to have your own program, which the name of the program makes sense to you. If I just say exception, it will not make sense. Okay, but if you have a program of your own, you will know what this message means. Null pointer exception, you know what that means. Something is null. Array index out of bound, you know what it is. Someone is using an index on an array which is outside the size. Similarly, if you read this name insufficient fund, you know what this message means. You know what this class means. So rather than using inbuilt classes to raise an exception, use custom exceptions. Okay, use custom exceptions. All right, so there is one more final thing, is a multiple catch block. We'll do that tomorrow. Okay.
Sir, what time are we going to have class tomorrow?
All right, so there is one small topic which is like 10-15 minutes. Okay, we'll do that tomorrow. Let's see.